Hello. Today I'm going to be looking at ChatGPT o1-preview, which has recently been released and has reasoning capabilities built into it. One of the things I'm interested in is how well it does at maths. In the past, chatbots have usually not been very good at maths at all. They get things wrong, but that's to be expected because they are, after all, large language models, and the clue is in the name, language. They're not really set up to do mathematics. But people are claiming that this new version of ChatGPT with its reasoning capabilities is apparently PhD level or something along those lines. So let's see how well it does with a simple maths problem. This is basically just a geometric problem. We have a set of points, A, B, C, D, E. We have lines between those points forming triangles. We want to know what the angles are of the triangles and the lengths of the sides of the triangles. And indeed, we want to end up knowing the distance between D and E. We have a subset of angles, which it's given. And we also, to scale this diagram, the distance between A and C, as shown there, is a distance of 461.9 units. So I've given it this information, and I've said, first of all, I want it to solve for the distance D to E and the angles in the triangle CDE, which is this triangle here. I've also asked it to give me a summary of the final numerical values for the angles and sides of the triangles. So it's gone on its merry way and done its reasoning for 53 seconds. And it's looked through things and constructed some geometry and angles, piecing together angles, analysing angles and sides. Oh, it sounds all very hopeful, doesn't it? Determining angle at A, applying law of sines, calculating angle DC, taking a closer look on analysing angles between segments AC, DC and EC. Oh, this sounds all very good. So we get to some calculations here. Now I've done this calculation by hand, so we can do some comparisons. So it's looking at triangle ABC, which is the triangle I started with as well. And we've got, if you recall, this distance here is between A and C is known, that's 461.9. And we know a few angles as well. We know that this angle here, alpha, is 63, and we know that beta is 102, which it's got as well. It's got those as the initial ones. It's calculated the angle at C as being 15 degrees, which is the angle which I get as well, 15 degrees. I almost feel like saying 15 degrees per hour, and you'll know what that means if you've been on YouTube enough. Anyway, back to the task at hand. Using the law of sines, it now calculates the sides AB and BC. For AB, which is side C in my diagram here, I'm getting 122.2 and it gets 122.25. And for BC, it's getting 421, which is A in my diagram, and I'm getting 420.75. There is a slight discrepancy there. That is presumably because on my calculator, I only kept the first two digits of each number which I calculated, and it may have kept more digits, in which case it's got some slight differences, but nothing untoward. So that's hunky-dory. So we come to triangle ACD, which is at the triangle I next calculated. So we have to do some subtractions again, and we get an angle of 25 degrees for theta, which is the angle at A, and it gets angle at A is 25 degrees. That's correct. Then we do the law of sines again, and we compute the sines, and we compute sides AD and DC. For AD, it is getting 802.92, and that is AD is D in my diagram, which is 801.7. And for DC, which is E in my diagram, I get 429.98, and it's getting 430.44. Close enough, given the potentials of slight inaccuracies. Then we're coming to triangle BCE. Again, we do a calculation to calculate the remaining angle, and it's getting 42 degrees for the angle at B, and I'm getting 42 degrees as well. That's good. So far, so good. Law of sines again. It calculates B to E, which is my F, as 801. I get 800.3. And C to E, which is G in my diagram, I'm getting 563.1, and it's getting 563.6. Again, close enough. So far, so good. Now we come to triangle DCE. And it is saying that D to C is 430.44, which is correct, which is 429.98 in my calculation. And it's getting C to E as being 563.6, which is G in my calculation, which was 563.1. So we should be able to calculate the angle at C. And I've calculated that angle from doing a simple subtraction using the other triangles. But it is saying angle at C calculated as 109 degrees from geometric relationships. But the angle at C is not 109, as you can see, it's about 5 degrees. It's very simple. We already know the angle from A through to D. We know the angle from A through to B, and we also know the angle from B through to E. So we just have to subtract BCE, ACB from ACD, and that will give us, as you can see here, will give us 5 degrees. But this seems to have just invented a so-called geometric relationship. Anyway, we'll continue on and see what else it comes up with. Perhaps this will be corrected at some point. So it's using the law of cosines to get the distance D to E. And D to E, it says, is 813.98. D to E is H in my diagram, and as you can see, it's 139.9. Given that F here is 800 units long, this can in no way be 813, because that's only from there to there. So that's clearly wrong. And then it's using the law of sines to obtain the angle at D of 41 degrees. I've done this calculation as well, and I achieve I've determined it's 159.4, which it certainly does look like, and it's certainly not 41 degrees. Anyway, it's provided a numerical summary. Now, I took the liberty of going through this a little earlier and actually asking it. You say for triangle CDE, angle at C calculated as 109 degrees from geometric relationships. What geometric relationships? Now, in the past, GPT-4, if it had been given this question, would have just given a straight answer. This new version has gone away and done some reasoning, and it looks very much like it has recalculated. It's attempting to do some recalculations and verifying their calculations for 109 degrees. Breaking down potential angles, tracing the angle, determining the cause, assuming geometric relationships. That's interesting. So it is working out ACD, ABC, and BCE, which I would expect it to do. You're absolutely right to ask for clarification on how I calculated the angle at point C in triangle DCE to be 109 degrees. Let me provide a detailed explanation of the geometric relationships used. Point C is a common vertex shared by multiple triangles. Well, that is true. And then it gives these values here, which I have also used. So it's got that essentially correct. It's identified that there are common point here, and these triangles use the angles on this point. But then it says to find the angle at C in the triangle DCE, subtract the sum of the known angles at C from 360. But this is not correct. There is nothing here which is 360 degrees. So it is incorrectly subtracting these values from 360 degrees to get 109, when in actual fact what it needed to do was to take the total angle taken at point C from A to D, subtract the angle at C from A to B, and the angle at C from B to E, which will then give you the remainder, which is 5 degrees, and that's the calculation I've done there. So the angle at C in the triangle DCE is 109 degrees. Calculated based on the geometric relationship that the sum of the angles around a point is 360 degrees, but that is incorrect. Revised calculation, and it's recalculated things here and obtained exactly the same results as it got before, which is not correct. So it's incorrect in assuming it's 360 degrees that it needs to subtract it from. Now, I unfortunately had some recording problems, and I did actually go on to ask it about this as I was recording this video, but that didn't get recorded, so we'll just have to look at the results that I got. I asked it, are you sure the angle around C in triangle CDE is not 360 degrees? Why do you think that it is? So it went away and it thought for 35 seconds, and it recalculated and piecing together angles. This all sounds very familiar, doesn't it? The mapping, the geometry. And this is the very interesting part. I'm realizing that assuming the angles around point C add up to 360 degrees might be mistaken. Instead, I'll calculate the angle between the sides DC and CE at point C, considering the spatial arrangement of C to D and C to E. And then it maps the geometry. I'm setting up a coordinate system with points A and C. then calculating point B's coordinates to solve the problem accurately. And this is the surprising thing. So instead of just doing the simple subtraction which is required in order to find this angle, which then solves the rest of this triangle, it has set up a coordinate system, placing point A at the center at 0, 0, and place point C along the positive x-axis there, and then recalculated everything that it's already done as absolute coordinates, which is totally unnecessary. Absolutely and utterly, totally unnecessary. And then it gets to the end of all of this, and it's saying the angle at C is now 21 degrees, which it is not. It is 5 degrees, as I've already shown. So even using absolute coordinates, it has still managed to get this incorrect. So it got the first 3 triangles correct, with some slight discrepancies, as I pointed out earlier, which are presumably due to rounding errors on my part. But this last angle, this last triangle has completely stumped it, and it's now giving, for example, D to C it thinks is 912 units long. That's E in my diagram, and as we've already seen, E is only 429 units long. 26, 21, 133, which is wrong because it's 5, 15.5, and 159.4. So there we have it. This version of GPT is supposed to be generating answers at a PhD level, and yet it cannot even solve a simple geometric problem which even a school kid could solve. I love this note at the end. This approach uses coordinate geometry to accurately determine the positions of the points and the distances between them. By calculating the coordinates, we avoid assumptions about the angles around point C and ensure that all calculations are based on the given information and geometric principles. I appreciate your patience and thanks for pointing out the error. Please let me know if you have any further questions or need additional clarification. Yes, I believe I'm running out of prompts for this version of GPT, so I'm not going to go any further with this because it's quite clear that it's got this wrong. It's had 2 goes at it. It's still not right. It's really not performing at the level I would expect if it's supposed to be so good. But then, as I said at the beginning, this is a large language model. It's not really designed for maths. And no matter what anybody says, it's not really designed for maths. And you can clearly see that here, that it's got the wrong answer, and it is not just slightly wrong, it is totally wrong. And so, given that, I would not trust this new version of GPT with anything to do with maths, and for that matter, anything to do with physics, which is based on maths as well. It's disappointing, but I suppose in some respects not unexpected. I could probably handhold it through and get it to give me the right answer. But what is the point of that? It is supposed to be able to give me an answer based on the information that I've given. And I shouldn't have to effectively do the calculation myself in order to get the right result from it. Anyway, that's been a very interesting test and disappointing, but from my perspective, not totally unexpected. If you have any thoughts on this, please do leave them in the comments. And if you have any thoughts on further mathematical problems we could set it, then also put those in the comments as well. I'd be interested to hear your thoughts and possible puzzles we could give this new version of GPT. Anyway, thanks for watching. I'll see you next time.